questions session. Coming up, separating us from an action-packed afternoon tea. Don't forget the action afternoon tea coming right after this in 30 minutes.
They're running away.
Stay activated.
We're locking the door.
So obviously Michael is not here, but perhaps Sean is close enough to Michael that he can answer some of the questions you might have for Michael. Floor is open. There you go, Anne.
Well, no one else. I gave everyone. I'm interested in the biochar. I think that was such an impressive video about the biochar. It's brilliant. We're going to make that go viral in my thesis. But I was wondering whether you were ever doing any outreach, like letting people come into the facility to have a look, and just getting it into the Logan News. I'm a resident of Logan, so I expect to see it.
So we haven't done any of getting things like the community into the group, into the facility. Last year we did about 460 people going through the 1970s wastewater treatment plant, which I thought was actually hilarious. But we're getting lots of people very, very interested in it. There's a Logan Eco Action Festival that we go to, so we're trying to do a lot of community work. The thing with biochar is still under the end of waste code for biosolids at the moment. So as much as we'd like to give in a way to the public to be able to use and that type of stuff, we just can't do that at the moment. So until we get an end of waste code for biochar, which is in draft at the moment, we'll see where that sits.
So that's one of those regulatory hurdles.
Yes.
So talk to Jordan here.
We've got the code. It's setting the precedent, I suppose, for the other states. So it's causing a little bit of fun at the moment.
So while we're on the biochar, I was just wondering, energy-wise, does it run itself? Like you mentioned that the bioenergy is used to dry the sludge. So does that come from the biochar process
So
itself?
it's heat energy neutral. So we do use for some diesel and gas for startup and that type of stuff. Electrical energy, we have a 1.1 megawatt solar farm on site. So that's enough to get us to ultimate design. So it's double the size of what you see there.
Brilliant. Sharon.
You said that 54% of the it's biochar, and I just wonder what is the rest?
What?
You said the 50-something% is the biochar, right?
Yeah.
So what are the other products that
As a
you're
carbon.
talking?
So it's the carbon side of it. So there's other macro and micronutrients in it, so nitrogen, phosphorus, potassium, all of those types of in the char itself. The carbon content's around 46 to 50%.
Okay, so it's carbon.
Yeah.
So does the nitrogen stays in it? Because I thought you might.
No.
It's all volatile. As soon as you heat it by 50, it volatilizes. There's
Not
an
bioavailable.
amount. Yeah, that's what we're testing.
So is N2 the final product?
Sorry.
And N2 gas? Or
Where it's being dosed, so it's not going through the gas. There's a minimal that's going through the stack that you see on there, but we're dosing for NOx and N2, so we've actually measured that for our carbon emissions because we are carbon neutral as a council, which is one of those which, yes, good at
Just a question here. Really impressive work, Joe.
But just a question. You mentioned about this biochar process to potentially solve the micropollutants issue. Did you do any tests to confirm that? If you still get any PFAS, microplastics, whatever, the micropollutants in your biochar product? And second question is about the market for this biochar. What you are going to do with this biochar? You give it to farms for free, or you use it for any manufacture any other products, or anything you plan to do or you are doing? Thank you.
Yeah.
I forgot, you have another one.
Okay, so to answer the first one, we measure the biosolids going in, it has PFAS, the biochar going out non-detectable. And then we've had to do mass balance of the PFAS, so under our license, because we've got a destruction rate of 99.999% as our license limit. So we're able to actually measure that and show that it doesn't go through the airstreams or any of the other, through the wet scrub or any of those types of processes as well. Other microplastics and nanoplastics, we've measured them in the biosolids and in the demonstration plant, which was a different biosolids and different drying technique. We were saying that it was about 60% reduction. In our current, it's between 84% and 90% reduction in our micro and nanoplastics. So it's a huge reduction that we're seeing. Now, what was it? Oh, markets. Fun. So, end of waste code for biochar is what we're waiting for at the moment, because at the moment we have to go under the end of waste code for biosolids, and there's only a certain amount of people that we can actually sell to. They are interested in it, but it's sort of looking at the short term, medium term and long term markets at the moment. So at the moment, short term is really around the agricultural sector, and so we've got lots of potential buyers. We're just waiting for that code to come through so we can actually sell it to them. They really want it for the carbon content, the water holding capacity, you name it. It's actually a really, really good product, and we know how it kind of reacts. All the work that Bernadette's been doing really illustrates why it's so good for the agricultural sector. Long term, yes, there is stuff that we can use it for that is higher value, but it just means that we'd have to do more process with it, right? So if we go down the activated carbon, there's other parts of that process that we would have to go through to go into that market, but it's definitely one of these areas. And then we've got about 2 concreting companies that are testing it at the moment so that it can go into concreting as well. But again, you have to look at that carbon cascade and where is it beneficial and where is it actually then that carbon route as well.
Just a question around volumes per year. How much are you producing, and what's the scale up? Is there a scale up happening?
Yeah. So biosolids, 34,000 tonnes per annum is what we're going through. We were estimating around 3,000 tonnes per annum of biochar, but it's around 4,100 tonnes per annum that we're doing at the moment. We have that stored on site, which is a mountain of char, but it looks great and it's great for those tours. So the other thing with that is, you're right, when we're looking at companies that are thinking around concreting or those really big agricultural sector, we've really got to say about what scale or volume we actually have to sell. At the moment, we're probably the biggest biochar producer around. Which it also makes it quite hard because you're saying this is what the product is. But yes, we are looking at scaling up. And so we're putting in a 3rd dryer in the next 12 months. That's not only to look at things like biosolids, but other feedstocks and looking at other technologies as well. So that's going to be quite fun.
I think just a question for Jason. I think you mentioned, I guess based on the survey, the financial risk or constraint, I saw it was the highest percentage. And I just wondered, does that translate to this, that perhaps government needs to incentivize or subsidize this technology? Is it what it means, or is it the expectation that...
It could mean a range of things. It could mean basically risk factor in terms of, there's risk factors in terms of not having regulations and not having frameworks around it. There were several in that financial sector section. I mean, I think one of the bigger issues at the moment, which was just being mentioned then, is volume. What are appropriate volumes to make something marketable? So there's many, those sort of, the question you're saying is actually interlinked with several of those other issues, I think, there. And it's about what do we need to actually take things to a more mainstream basis, if that makes sense, in terms of volume, the point which is being made. And also, then people will invest once they know there's a stability in the market and those sort of things. So it's sort of a, like I said, I suppose what in a sense, what we focus on is that system, in a sense. Everything's interlinked rather than being individual or a singular item, even though it was shown there for simplicity reasons to make it arguable. Does that answer the question?
Yeah. Thank you.
Matthew.
Thanks to all the presenters. Really appreciate hearing from everyone. I've spoken already to Joe about a number of things coming from the wastewater sector. But I do have another question. Our sector is not really known for moving particularly fast. No one wants to be the first mover on new technology. On the other hand, we live just up the road, and I look at Logan Water and you seem to move fairly quickly. Why do you think that is? Like, what are the drivers? what are the arguments that you're making in your business around biochar that
Made it stack up.
made it stack up and expanding the capacity and looking at alternative feedstocks as well? So I'd love to, whatever you're prepared to share at the moment. Otherwise, we can chat offline.
Well, yeah, Logan's a little bit of an interesting one because they've got different drivers. So at the moment, like I was saying, we're carbon neutral, which is unheard of for a council and water utility. And the reason being is that we decided to do that in 2019, that we were going to be carbon neutral by 2022. That pushed us into a lot of new technologies to go, okay, how do we do this and do it sustainably and reputationally? So things like the gasification facility tick those boxes. So we actually have something to grab onto and say, one of our key drivers is to be sustainable, prudent and efficient, and around that is these green projects. So that's where gasification kind of sits. The other thing with this, and it comes back to how you do business cases. We are very risk adverse, and there's reasons behind that. There's public money, so we don't really like going and using technologies and that type of stuff at full scale. This one moved quite fast because we were able to do the demonstration plant and then the full scale, and we got a lot of support from the water industry to do so.
And arena funding.
And we got arena funding of 6.23 million for the demo plant. So that was a good push. The next kind of phases that we're looking at are really around looking at things like the marketability first. So we look at that prior to actually going in and going, can we actually make marketable products? The other point that I will make is that that project stacked up by itself because of haulage. So we would have been able to pay off that the facility in 10 years. And that's the kind of thing where we go, how do we do that?
Wonderful. Sean.
So my question to Howden, I'm just wondering, your technology is relatively very new. So do you believe what's your expectation of the nitrification for AOV, NOV from your MAVI system? And what could be if you make a scale up for this one, what could be the major hurdle do you think that you can face?
Yeah, thank you. Thank you for the question. I think it should work. Some people already used MAVR for urine treatment, but still the same sort of issue that the instability of this process subject to FMA, FA concentrations. But if all the theory works out, and there's one point I didn't actually say was the carbons. We are unsure whether the carbon in urine, whether that is easily biodegradable to facilitate this proposed particle identification process. So we ordered some creatine, to see whether we can get what we observed with like acetate or other easily biodegradable carbon. But if that works out, and then theoretically it should work, but then, and also upscale of MABR seems to be fairly feasible. We currently also working with Rotocorp on their pilot MABR, also actually demonstration scale 600 cube per day, and a lot of other utilities are also using MABR, like Gold Coast is doing full scale, and the water care in New Zealand also doing full scale and also pilot scale. So it seems like a durable technology, and if that coupled with a new operation, coupled with urine treatment, seems like a scale can be scale up technology.
Okay.
So in urine, we got 2/3 of the COD is acetate. So
Oh, acetate?
yeah,
Oh, not,
after hydrolysis.
oh, not creatine.
Initially, but after hydrolysis. So Sean and I, we work with hydrolyzed urine. It's pretty much all acetate.
Oh, that's really good to know.
Yeah.
Because I did read your paper. I thought that's just synthetic. So
The
you add
creatine is
acid.
very small organic compounds. Yeah.
Oh.
Very
So-
small concentration.
I just had another thought. So we've been talking about ammonia loss the whole day, and you're looking at greenhouse gas emissions. And you normally we don't have any issues with ammonia in wastewater treatment systems because there's very little of it and the pH is low. But here we actually do get quite a bit. What's the fate of ammonia after it's in the atmosphere? Like, what does it convert to, and how long does it take, and does it have a greenhouse gas potential itself?
I think ammonia does not have greenhouse gas potential, but really it has.
Yeah, into it's like there's
It's NH.
UNH, yeah. So,
Oh, NH,
yeah.
yeah, if you convert it.
Yeah,
Oh,
so we do, it's our scope 2 emissions really high.
that's your scope 2
Yeah.
emission?
Yeah, and a wastewater treatment plant.
Ammonia.
Yeah, it's like wastewater treatment plant process. But anyway, yeah, it's still.
So
Yes.
it's
something to account. So
But
we
this
need to.
MABR, another benefit is you will have less ammonium coming through because there's no active stripping. It's
Yeah.
bubble-less. So you would have some ammonium coming through the membrane to the membrane source, but then that's highly concentrated. So you can still absorb that back in if it is MABR. But if it is just bubble aeration, it's hard to control the later.
Some of the stuff that Sean and I make, or Abraham has been using in Vermont, we put it straight onto the soil. And if you say 10% volatilizes, what's the GHG potential of that? And so are we actually doing worse overall?
Yeah, that's a good point.
Something for you to study, so you can help us on that. Matthew?
Just to comment on that, you're also displacing, if you're reusing your nutrients, you're also displacing the production of that nutrient somewhere else in the value chain. So you should be able to count that against your product and the net value, I guess, carbon potential across the value chain that you're actually displacing some of that. And nitrogen, 10 or 12 kilowatt hours a kilogram, phosphorus is like 14 to 16 or something kilowatt hours per kilogram. So you can, obviously it depends on the background energy mix that they're using to produce those chemicals. But certainly there's, got to look at in my opinion, got to look at the whole cycle. So not just the wastewater treatment part of it.
Abraham?
Okay. I have a question for Haran about the environmental analysis of urine diversion. And I'm curious about the capital investment in urine diversion equipment, like the urine diverting toilets or even just urine diverting piping and tanks, because there's very low throughput in that per unit tank or pipe in all the houses. And I wondered if that was part of the environmental analysis of implementing urine diversion.
No, we didn't consider that infrastructure part. We only considered the urine treatment part, like MBR or electro. So the infrastructure of having urine collection was not included in the scope.
Any further questions?
Maybe further to that, so that's also like what Matthew was talking about. It's sort of a counter. You would have, if you have these infrastructure built within buildings, then you delay
the future upgrade of wastewater treatment plants because of that reduced nitrogen. But yeah, maybe a comparison of that would be interesting.
Yeah, that would be fascinating.
Yeah.
Are you all satisfied?
Yeah.
We're a few minutes early, but thankfully, Aldo here was show you a couple of slides so that you go into morning tea prepared. So we're going to let the speakers off the hook. We invite